What in the world is the BGP best path selection algorithm? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right, we are here to actually discover what in the world we can do to help BGP pick its very best path, and why we need to do so, of course, is going to be with us to answer that, Anthony Segura. Anthony, welcome to the show.
You know, we've done so many episodes together already, Ronnie, and that was the first time it caught me by surprise. You see that? I was working on something like, oh my gosh, we're live.
Yeah.
Awesome. You know, this is such an exciting episode because Border Gateway Protocol is unique in so many ways, as we know from our IGPs. And one of the most unique things that it does is it has all of these attributes that we as administrators can manipulate. And there's not just one single metric. Like in OSPF, we have the bandwidth that is influencing OSPF cost. And that's how it works. So there's a cost associated to your different paths based on bandwidth. Here, it's much more complex with that than that. Now, Ronnie, what I've done is in our topology, just so you know, I've done EBGP peerings between R4 and R2. We had set that up all together live in the studio. And then R5, R3, I added behind the scenes. I took all of the prefixes that were in those two ASs and I advertised them into BGP. And I made sure that one of those prefixes was in both of those ASs out there. So watch this. If you go to the R1 device and you do a show IP BGP to look at the BGP table, you will see that for this prefix of 10, 100, 100, there is two options to get there, Ronnie. We could go to the AS 65004, or we could go to the AS 65005.
Right.
So those two ASs offer a path, offer an avenue to get to that prefix. What did BGP choose? Well, you can see that it picked as best the 192.168.04. It did that because it kind of panicked. Everything was the same. The multi-exit discriminator called the metric here is at 0. The med or metric is at 0, so it couldn't distinguish that way. Both local preferences are 100, couldn't distinguish anything there. Both weight values are 0. Both AS paths contain only one AS, so they're both the same length. Both were redistributed in. So it needed a tiebreaker. It went for the lower router ID, I'm thinking. So that's what's going to happen. If BGP needs to break the tie, it will, using some fairly random way to do it, like lowest IP address.
So I think we had pointed this out a little bit earlier, but just as a reminder, if we look over on the left-hand side, we notice that one has just the asterisk, which means that it is a valid path, but it's not the best. And this is how we can distinguish between those two possibilities. So this is what happens out on the internet, right? There may be a single route like what you have here, 10.100.100.0, that it's possible to actually leave two different interfaces and eventually get there at some point, right?
Absolutely, right. I mean, there's going to be, think about the internet, there's going to be all kinds of multipath situations. BGP has a very sophisticated sequence that it goes through to pick the very best one. And Ronnie is going to teach us a way to memorize that. So cool. I kind of had it memorized, but I sure wish I had known Ronnie 20 years ago because he could have helped me to memorize it in a better way. But first of all, let me show you this. Let's go over to our friend Google and let's go to cisco.com actually in the web browser. And what we're going to do is we're going to find the documentation on this and we're going to pretend that Ronnie can't Google search. When would Ronnie want to look up this information and not be able to Google search? When he's sitting in the CCIE lab exam. When Ronnie's in the CCIE, they'll give him access to this page right here, the all product support page. They give him that. He can go wherever he wants in here. So they give them the documentation
So this can be done during the lab?
during the lab, but
Okay.
they are not going to let you Google search.
Okay.
Yeah. They also won't let you phone a friend.
Oh,
Yeah, no phoning a friend. I was at a lab once where a guy went to the bathroom and he had smuggled in a phone and
Oh.
he called Cisco TAC and was asking them a question, which he was pretending it was
Right.
production. Hey, I'm here at my data center, blah, 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 blah. He was asking a question on his lab. And of course they caught him because they're surveilling the whole place. So that was pretty funny. Ronnie can use these documents and he's going to go in and he's going to find the BGP best path selection algorithm. And listen, I got to be honest, I'm showing you this because it is in a weird and wacky place. You would think that it would be under the iOS software,
Right.
and then you go into the BGP chapter. It's not there. You got to go networking technologies. Then you got to go to IP routing. Then you have to go to the troubleshooting tech notes. Then you'll see the
gosh.
BGP best path selection algorithm. Now, Ronnie's laughing because he's like, I never would have found that.
No.
And he's probably laughing at me because I knew right where it was.
Yeah.
And that's from pure looking it up a bazillion times.
Right.
So one of the things we practice if we're doing something like the CCIE is we practice with the documentation. You have to know the documentation as well as I just did, in my opinion.
I'm definitely making a note of that.
Yes. Be very educated on what's in the documentation and how to find it. So, Ronnie, there's a couple of rules right up front that BGP will do. It will ignore paths. And let me zoom in on this so everyone can see it. It will ignore paths under certain situations. Like if the next hop isn't accessible, toss it. It's gonna ignore that path. It won't mark it as valid. So there's some rules that exist. Now, once those rules are met, what is the very first criteria it looks at?
Weight.
Cisco's so egotistical. They look at their own weight. And that's funny on multiple different levels, I suppose. So they look at their own proprietary invention called weight. And notice a higher weight is better. This is the opposite of Jenny Craig. So the higher the weight, the better. And that is the first thing that's looked at. So if you're like, wow, you know what? I want this router to choose the other path. Guaranteed. You would do weight.
Yeah.
Because it's guaranteed to work. It's the first thing it looks at. Next is local preference. Next is AS path. Did I skip one? I did skip one. So the third one is, did you bring it in with the network command or did you bring it in through redistribution? The fourth one is AS path. So there's this long, long list. Look at this. It goes through 13 different steps. And then it has the arbitrary lowest neighbor address. And that's, of course, what happened with us, I believe. So we have all of these different ways to tweak things to manipulate the path. And we're going to demonstrate one right now.
Yeah. Now, Anthony, as we take a look at this list, this is probably something that I'm going to need to really memorize then.
It is. Here's how I approach this. I'm not a big memorization person. It annoys me when I have to. See, let me explain why. I was really annoyed about memorizing this because I know where it is in the documentation. And when I'm working in a data center, I can just look it up. So that's what annoys me about memorization. When I'm having to memorize things, I could just and would look up. But I kind of did. I was real close to having this memorized. Like I knew weight was first. And I knew local preference was pretty high up there before AS path. So I kind of had it memorized. But as I said, I wish I had known Ronnie. Ronnie, give us a nice mnemonic that we can use for the key points of these steps.
Yeah, so this is the one that you'll actually see appear just about everywhere across the internet. You'll see them in blogs, you'll see them in Cisco posts everywhere, and every forum that's out there. But the way that I also remember this is we love oranges, as oranges mean pure refreshment. And that gives us the first 8 points. And I believe that those are the ones that we can manipulate as well. Whereas some of the ones towards the end, like the router interface number, right? Those aren't ones that we can really manipulate as much, but at least those first 8. So we love oranges, as oranges mean pure refreshment. that should at least give you a memory hook that you can use.
I like it. Now, at this point in our episode, I must give full disclosure. Ronnie and his family own shares of Tropicana.
Yes.
So that is why he is actively promoting that mnemonic.
Exactly. Because
All right, Ronnie, let's do this. I love it though. It really is a cool way to remember those. We love oranges. All right, let's get to some path manipulation, shall we? So we agree, everyone agrees, that there are two ways to get the 10, 100, 100. The way that was chosen through an arbitrary, silly thing is the R4 path. Let's poison the R4 path so the R5 path gets chosen. So what I'm going to do is I'm going to go over to the R2 device. The R2 device peers with the R4 device, and I'm going to go in and I'm going to poison the AS path through what we call AS path prepending. We're going to take that 65004 AS number and we're going to duplicate it in there. We're going to prepend it in there. So we're going to poison that path and we should get a cutover to the R5 path. Let's try it. How we do manipulation of most of our attributes is using what's called a route map. I'm going to say route map, my map, permit 10, and then inside the route map, I'm going to say set AS path prepend, and they have this new invention. Relatively new invention. This did not exist when I was taking my CCIE lab back years ago. This didn't exist at all. It's the last AS command. I love this. And you say how many of them that you're going to drop in there. So I could say, all right, look, just give me one prepend of the last AS in the list. So you can kind of automate this. And then I'm going to exit from my route map configuration mode. Notice what we're doing in this route map. In fact, let me do this. Do show route map. In this route map, we have no match clause set, Ronnie. So we are matching all prefixes. And then we are setting some AS path prepending. The last AS, please prepend it to poison it. And then that's it. We are now going to go into router BGP 65213, and we are going to go to the neighbor, the R4 neighbor at 192.168.0.4, and we're going to say there's a route map that needs to be applied, and that route map is going to be called my map, and please apply this in the inbound direction. So all those prefixes that are coming in now are going to get prepended, and if we go up to the R1 device, Ronnie, if we had a drum roll sound effect, now would be a good time for it. If I do show IP BGP, there's the old table up above that we can see. If I do show IP BGP now, look at this. The 10, 100, 100 is still preferred through R4.
Oh, no.
So now we need the sound effect of murr, murr, murr. Now, I wonder if I went up there too fast and did the check. I wonder if convergence hasn't taken place yet. Let's check. Look at that, Ronnie. I was too fast there on the draw. BGP is slow to converge. That is by design. You don't want some hyper fast converging protocol when you're dealing with BGP because the internet would be sheer chaos. There'd be machines smoking and bursting into flames because they'd be working too hard. BGP, trust me, is slow to converge by design. So convergence has happened. Ronnie, something really super interesting has happened. The R4 path is gone.
Right.
Is it really gone? No. But it's been kind of poisoned out of existence for that prefix. If the R5 path were to go away, sure enough, the R4 path gets reintroduced into this BGP scenario.
And what we're seeing there on the top line of that, where it actually shows us the AS path twice.
Yes.
That is the
That's
prepending.
the prepending.
Okay.
Yes, and that happened for this prefix, and it caused R5 to be the new destination. So that poisoning, that lengthening of the AS path, caused the new path decision.
All right, so question here as we do this. So if we needed to make this happen, Why did you choose AS path instead of wait, since we said that that was kind of the first one?
I just think AS path
Okay.
is cool. And also I chose it because I do stay away from proprietary solutions. I don't like
right.
proprietary solutions, and I try to avoid those whenever possible. Wait is a Cisco proprietary thing. I just demonstrated AS path prepending. That is a standard thing. Juniper does it. HP does it. Cisco does it. Anyone supporting BGP does it. AS path prepending, it's something we do.
Yeah. So this is actually very neat. Now, even though we're only taking a look at one of these, right? So you just showed us AS path, and we talked about that there's 13 of these things, right? 12. Well, how do you go about mastering something like this? Probably the easiest way is to take a look at that output that we just saw on the screen, and instead of just using AS path, is go through and see if you can identify how to use those other ones, such as the med and everything else, and look at the outputs of it as well. What do you think?
I totally agree. That is such great advice. I went back to the documentation. It is not a bad idea. I'm not kidding. Like, if you really want to know BGP, and I encourage you to really know it, you would go through, you would print this page out, and you would go through and you would highlight each of these as you fully practice with them at the command line. Practice with each of these manipulations to make sure you know how to configure the manipulation and the manipulation functions the way you thought it would. There's some little surprises in here. I'll give you just one quick example. Wait, we know, is Cisco proprietary, but it's also local to the router where you configure it. The wait is a local only thing. It doesn't get transmitted to other routers. So wait is for manipulating a path decision, but only on that local device. So please play with all of those if you really want to know BGP.
Now, speaking of that, so as you were talking and as some of the BGP concepts that I learned about, the very fact is this is really that unusual jump from that CCNA level of thinking that metric is the only thing that matters. Now we have the ability to be able to kind of choose which way we want the traffic to go, and not just based on one thing, which is that metric.
That's right. It is a whole new paradigm. We are discussing here a routing protocol that has all these different, I've always described it this way. I just like it. Not sure why. Maybe because there's just, don't you love it when you see like some command center? I suppose a great idea, an analogy that I've always thought of is the flight deck of a Boeing 737. So I'm a pilot, but I fly little 2-seat Cessnas. But when you go up into a sophisticated airplane, there's tremendous number of dials everywhere. That's kind of what I think about BGP with its attributes. There's all these little tuning knobs, Ronnie, that ISPs have at their disposal to influence how traffic goes out of the AS and how traffic goes into the AS. And just one final point in this episode to make. Remember, BGP is one where you can control how it flows in and out of your AS, but it doesn't let you trample on others. So you can't necessarily control, very few exceptions, you can't control someone else's AS. Does that make sense? Like,
it does.
Yeah. You can't be like, all right, and when I send it to you, you have to do this with it. That's tough to do.
Yeah. Now, Anthony, we're pretty much at the end of our time for this episode, but I did notice one other thing that we're probably going to have to talk about in the future, which is the idea of,
I knew you were going to bring it up.
Of that little R that we also ended up seeing as well.
Yeah, Corolla, our producer, if you could, thank you, Corolla. She's brought us back to the command line. Ronnie doesn't let anything go by. What a sharp eye. Ronnie's troubled by these entries in here that have an R. Notice they don't have an asterisk, so they're not valid. There is a problem. And R stands for Ronnie. No, R stands for rib failure, and I promise you I'll explain that in the very next episode. How's that?
All right, sounds very good. Well, you heard it right here. You have now seen that the best path selection does require you, especially if you're preparing for the exam or even for the CCIE. It's probably better if you memorize them, but make sure you practice them is actually the key. All these are going to be very valuable to you on that particular context of how you're actually doing this. But there's also a lot of other things that we took a look at as well. So make sure you review this episode, a couple of times if you need to. But this is a great place for us to sign off. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.